Next, I would like to invite our next speaker, Dr. Nataraj sir. Sir, please.
That I'll just briefly give you idea of what are all things going on in large language models, and then we will take I think some part of it mainly on like Indian languages, what is happening, or what approaches are there, what people are trying to do. So basically, I was trying to there is some paper by Microsoft India, so which was working on the developing this large language models for Indian languages. So I'll discuss some strategies which they used, and what is the gain they achieved using that. So, but I'll start with some basics of these large language models. Okay, so those who know large language models and a bit of it, just bear with me. Okay. Okay. So, so what is large language models? So first of all, the language model itself. So these are the models which we design to understand and generate human language. Okay. So the way we humans are, we are able to do it. Can models also do like that? See, we all understand different languages. We identify from the language that what is the intention, what is the sentiment. Okay. So we derive a lot of, we understand what the from what we listen, and we decode that text, and we come up with some conclusions. So, and also we produce speech also, means we produce text also in different languages. So we are, humans are able to do it. Can the machine able to, can we make a machine or a model which can do the same thing? So here the word large refers to two things. Okay, the first thing is the large amount of data. Okay, we are going to be, we are not talking in like some files are in kilobytes, not even megabytes, it's in gigabytes, and a large amount of text data which we are processing. And then the second thing is the large also corresponds to the model. So okay, so what is the model means? The model is one which approximates something. Okay, here we are trying to make a language model, so it's trying to approximate the language. Mathematically we are trying to approximate a language. Okay, that is the model. Okay, so what are model? I think most of us know what is neural networks and all. So here the model which is approximating the language is the, mostly the large language models are trained on deep neural networks. Okay, so so we'll have large number of parameters in this deep neural networks. Okay, so that is the word large language model. Large corresponds to two things, that is the amount of data, the text data which we are using, and the number of parameters in the model also is very large. Okay, we'll see some examples. So I think, so when I say large language models, it is better for nowadays people, if you want to understand why we want to do this, is because all of us are mostly using the chat GPT. Okay, so this is one of the large language models, and recently this GPT-4 is also there. So these two things, I think many of us are using these models. Okay, using these tools for day-to-day life. We are using it to generate mostly many people like I and most of the companies, people are using it for writing code. Okay, so it's generating code with very good accuracy, human like accuracy. And there are a lot of other things. I think many of you have used chat GPT. It is almost replacing Google for searching, because it gives us precise answers, and all this is based on the large language models. Okay, so there are many language processing tasks. I think like from text generation, summarization, to translate from text from one language to another language, sentiment analysis, document summarization, we can go on and on. So all that chat GPT-3, these language models can have a lot of applications. But like how it's, see, for example, few years back, if we had said like something like chat GPT will be there, is like almost like we felt impossible. Okay, so okay, the deep neural networks were doing good, better for the language processing task, but the accuracy for to interact like a human, that was not there. So it is chat GPT, that is a GPT 3.5, which changed the whole landscape of these large language models. So previously also there were a lot of language models, but this GPT 3.5 has changed its impact is visible to all of us, and all of us are using it. So today we'll see the basics of it, and then we'll go to specifically for Indian languages, what is the current situation and what we can do. Okay. So why we, okay, before I go it, why we need it for Indian languages also? See, one thing is, many of the developed countries use, for everything they use their own language. Like if you go to Japan, they study everything in Japanese. Even they are developing software for different companies outside Japan also. All their development framework, the coding, everything is in Japanese. Okay. And this many European countries also, they do not follow English. Okay. Not all countries use English. So, and these countries are definitely doing better. Okay. That is one thing which I feel in Indian context we are not doing. So we are mostly towards English. And the problem with the using English is that, see, it's a language barrier. Okay. Rather than our intellectual capability, I feel this using English for everything makes us creates a language barrier. And so some people who are capable to be do better, because just because of lack of this English language, they will not do well in life. So using our own language in everything is one thing that India should take up, so that we'll go to the levels of others. Okay, we can have the English as well, but also trying to do things in Indian language will be very, very important. Okay, if you want to grow fast, if you want to be developing too fast, I feel using our own language and learning in our own language is more beneficial than just using English for everything. Okay. And it is not just for that. There is, like in everything, like if I want to use these large language models in India, so people don't always use English for everything. Okay. Not everybody knows is good in English, or may not be want to use English, because many business people, they just bothered about their business. Okay. So English is not mandatory. So if you are running a small enterprise, let's say you are running a small hardware shop, so there, see, we can use language models everywhere. Okay. But just because it is in English, it is not used anywhere in India. So that is one barrier which we can remove using developing the models in Indian languages. Okay. And see, all customer supports, for example, we are going to build chatbots for airlines, we are going to build chatbots for insurance companies. See, all these companies need not have English as their communication, because many people do, see, elderly people may not know English, or they don't want to use English. Just because of this, English is the most spoken language in the world. We are forced to use that. Otherwise, there is no necessary thing to use English. So we will lose customers if you don't try to model things in Indian languages. We will not be able to exploit the benefits of these models. And also, like farmers and people who are using government schemes, the government of India, for example, we have they are coming up with a GPT for farmers. Okay, something called Kisan GPT, and there are some more other farm GPT. There are many GPTs for the farmers. So they will ask a question, what are all the schemes available for me in India, from the government of India? It will just give the answer very quickly. Otherwise, getting any information, the farmer has to go to the that government office and get the information. So it's better to use the chatbots based on these large language models in Indian languages. And also, see, there is a very large amount of people. Many people in India are working on speech recognition also for Indian languages. So if you combine this speech recognition, and so that we can, whatever the person is speaking in native language, we convert it to text, and then use large language models in that text, then we will be able to serve many people in India. And especially for the government schemes, the government scheme want to develop its own data, and it want to train using that and give feedback using that data, which may not be available in ChatGPT. ChatGPT has its own constraint. It is, for example, it is developed in 2021 or so, 21 or 22. So we don't have any access to the data before that. Okay, and these models are not free. Okay, for example, ChatGPT models, they're free to use, but if I want to fine tune the model for my specific purpose, I have to pay. Okay, still today, if you want to use any of these ChatGPT 3.5 or GPT 4, we need to, I think GPT 4 we need to pay even for using, but GPT 3.5 is free to use. But if I want to fine tune on my particular problem, like for example, government schemes or Indian insurance company, it is not free. Okay, you need to pay for every for training also, and also for access for generate. Every time we generate a response to our customers using this chat gpt api, we need to pay. Okay, so one of the, okay, let's go to some basics of these large language models. Okay, so the idea of these large language models is mainly based on transfer learning. Means, so what we will do is we take a text, okay, lot of text, and we train for a particular task, let's say task x. Okay, but the same model can be used to for many applications. Like if I want to use it for a task y, I just take a small amount of data for the task y and fine tune this model on the large this data, the model which we developed for the task x, which is having large data set. Okay, so this is the very key idea. So using, it's not like large language models. If I build for one task, it is going to be used for that only. We can use that as the basic base, and we can fine tune it for different applications to do the transfer learning. Okay, so what is that? For example, if I want to do language processing, what is the basic task which we can do? It is language modeling. Okay, so what is language model in a very quickly? So see, in terms of NLP, the language model is like we want to predict the probability of the next word given some previous words. Okay, so you have, let's say you have a vocabulary of 10,000, 20,000, whatever number of words. So I want to given some words, what is the probability that next word going to be, let's say we have many words, let's choose one word, yes. Okay, so what is the probability of yes when the previous word is good? Okay, so like that we can have many conditions on which we are going to guess the probability of the next word. Okay, so this is the basic language model. So that is, we are going to predict the probability of the what will be the next word in a text given some previous words. So if you train the model for this estimating these probabilities, we can use it. Once it is trained, we can use it for many tasks. Okay, and like all the tasks which we did, sentiment classification, text generation, like ChatGPT is nothing but a text generation model. Means if you give the question, it will generate the text as the response. So text generation, text summarization, and question answering. So all the tasks, we just, the basic model is the language model which tries to predict the probability of the next word. So using that model, we can fine tune for different tasks. Okay, so coming to the network wise, so what is these models are built on? Okay, the latest models. So we are talking about the latest models. These models are built on the transformer networks. Okay, I'm going a bit fast. I just give you the ideas. Okay, those who don't know can quickly get what is happening. Okay, so transformer networks are nothing but deep neural networks. They have the these blocks. Okay, the most important part of the transformer network is the self attention layer. Okay, then we have a normalization layer, and then some feed forward layer, and there is a residual connection. Okay, so this is the main component, or I would say this is the main network, deep neural network block. Okay, using this you can create multiple blocks and generate any of the models. The latest GPT and every models are based on the transformer models only. Okay, so what is this self attention? So self attention is, see we, for example, I want to do a sentiment classification. There is a big amount of text, so I want to focus on particular words only. Okay, if some is there, it's like beautiful. The word beautiful says a good feeling, right? It's a positive sentiment. Okay, so we want to give attention only to few of the inputs, not on all the inputs. But how do we decide which particular input is important? Okay, so what we do is that that is also embedded into the model. That is, we have weights. Okay, these weights are trained in such a way to select particular words with particular inputs in the these x1, x2, x3, these inputs, and give important or the weights to these inputs which are important to relevant to generating the corresponding output. Okay, so let's say if I give you a text, then you will find out the important words in the text like beautiful, fast, quick, very nice, very comforting, some words which will give you positive intent, and maybe some words which are giving negative intent, poor, bad, very slow. So like these words we can pick, we humans we do it, but the same thing can be accommodated into the model by using this self attention layer. Then there is a normalization layer. So the normalization layer is, it helps in training, because see, we have the data. So usually we model the inputs using embeddings, means some vectors. We generate the words using some vectors, and these vectors may have very different distributions. Okay, so this layer normalization, actually at the output of each of the layer, they normalize the outputs to be with uh, some uh, some mean and some standard deviation. Okay, so what is the advantage of doing this is, so always every output of the network will be within some definite range. By doing that, our training will be much faster. Okay, because we know exactly what is the range. If it becomes too large or too small, so when we are training a neural network, it will always give problem of the training of the neural network. So it helps in that. Then there is a residual connection. Okay, this residual connection helps us to find out, see, some part of the network I don't want to, I want to know this output also and what was the previous output also. Okay, so this part of the network may be doing a lot of complicated things, so this information might be lost here, so I don't want to lose that information. So I will use a residual connection. That is, I will take the current output also and previous output also, and take the further for the processing. Okay, so these residual connections help in many problems where networks become too complex, and we will lose the information because they are too complex. So these residual connection will help us to retain some previous information. Okay, so in a summary, so we use these different blocks. Mainly the main important aspect of the transformer network is the self attention layer, which helps us to focus on some particular parts of the input which are relevant to the output. Okay, so before we go into what is this chat GPT and all, I would like to give you a small example where the mostly these ideas have come from. So this is a model of for the machine translation. Okay, so here it is in one language, the green which arrived in English language. This is in some other language, the output is in other language. So it has got two parts. Okay, this is an encoder part and this is a decoder part. So in these blocks we see here, these are transformer block. Okay, this is one transformer block, this is one transformer block. So we have many transformer blocks. Okay, in the this encoder. Okay, and we are taking the, so for self attention, what we do is we use all the inputs. Okay, for generating any input, here we take the inputs from all the inputs are given to every transformer block here. Okay, so and so these are single word inputs, so these inputs will generate some outputs. Okay, so what we do is, while generating the output in different language, we use the decoder. So the decoder uses the outputs of the encoder. Okay, and the source language and the target language are separated using some marker like S here. Okay, so it uses the encoder output and the generated output to generate the output in the another language. Okay, so what is it doing is, encoder is trying to find generate some representation of these inputs, and decoder is having some attention layers. It is trying to see which words are responsible for generating a particular word in the target language. So using these attention layers, so we will be able to obtain the text in the another language. The important part is the output is generated word by word. Okay, so we generate a start, it will generate one word, and then we use this output as an input to the next time. Along with all the encoder outputs, we use the whatever is generated as the input to the next word generation, and we go on generating the output like this. So the next word generation is dependent on the previous word generated, as well as the all the encoder representation for all the input in the source language. Okay, so just keep in mind, this is the idea used in machine translation. So all our models, main models in the large language models, are built upon these encoders and decoders. So what we saw, first we saw the basic block is transformer network, which uses self attention layer mainly. And then we saw that there is an encoder and a decoder. The encoder gives us representation and decoder helps us to generate the text in different language in this framework, but you can use the same framework for many different tasks in language modeling. But we will use these encoder and decoder models in large language models. Okay, so there are two mainly very famous or the latest language models. One is called BERT, bidirectional encoder representation from transformers. So okay, so this is a this is one language model, and there is a GPT models which mostly we are all aware of, that is a chat GPT is from this GPT. Okay, so the BERT uses only the encoder part. So BERT uses the encoder part. The encoder part is used in BERT model, and GPT uses this decoder model. So we'll go slightly deep into what is happening. Okay. Okay, so let's start with the GPT model. So what is happening in GPT model is, see, this is the transformer block. Okay, so what is this GPT uses? GPT uses this decoder block. Okay, and BERT uses this encoder block. Okay, so what is the GPT is? GPT is a text generation network. Means it's the goal is mainly to generate the text. Okay, so if I give, so for example, the first word is so, I will give this input. What should be the network generates, what should be the output, what is the next word for this so. Okay, and this is a transformer network. Okay, and it generates this word, and we give this as word as the input to the next block, and it generates the next word. And so, and we see while generating an output, we also take care of the previous inputs. Okay, previous inputs and also previous outputs, and we generate this new word. Okay, by enforcing this, we are able to learn the linguistic nature of the sentence, or we generating the words. Okay, so any questions you can just, I'm not sure, like how can I see the questions? I think I'm going bit, if there is any questions. Okay, okay, if there is any question, Animesh sir, can you please help me with
Yes,
that?
yes.
You
So
can ask
now,
question.
now I have opened the mic. Anyone having the question, they may ask.
Yeah, yeah. Okay.
Mic is open now.
Yeah, yeah. So otherwise I'm feeling like I'm just blabbering.
So any question from
Yeah.
anyone?
So you can ask any, and you can just interrupt me, and I'll go on, but you can just ask me. Okay. So these GPT models are nothing but they are generating the text using the previous inputs as well as the previous outputs. Okay, this is called auto regressive generation. Means it generates the output based on the previous inputs and outputs, and generates what is the next word. Okay, so what happens is, see, you have a vocabulary of words. Let's say we have some 1,000 words. So here at the end of this network, we will have the softmax layer, which will generate a probability of each possible word in the vocabulary, and the one which is having the highest probability, we will choose that particular option. Or sometimes there are, like, we don't choose the only the highest probability, we choose multiple options. Then we use a search algorithm called beam search to obtain the most probable outputs of all the inputs. Okay, so this is the most the basic network of GPT is this much only. So it uses a transformer blocks. See, I put only one block here, but in the GPT model there will be lot many more blocks, but it is a decoder network of the machine translation. So that is the same thing. So it just generates the training model. So once, see, for the chat GPT, we are just generating the text using these models. But for the other tasks, we can remove these outputs at some points here, and we can add some extra neural networks and train for that particular task. For example, if I want to classify for the sentiment, then I can what is that? I can stop after this is trained. I can tap at some point and put one layer here for the classification of sentiment classification. You can use the same model for sentiment classification also. So all these chat GPT models are again trained, fine-tuned for specific tasks, and they do very good in those tasks also. So but we are using, as far as we as concerned, we are mainly using it for the text generation, but we can take that same model and fine tune it for many NLP tasks. Okay, so the BERT is, what is the BERT? So BERT uses, see here you see we are using only the previous inputs. So we are not, for example, to generate output here, we are not using this long and these embeddings we are not using here, or the embeddings means the vectors. So we are not using any of these vectors. So we are using only, for this we are using previous one and the current one. For this we are using previous last two inputs and the current input. So this type of networks are called causal networks, means they depend only on the past inputs and outputs. But here in the BERT, it is bidirectional, means we also use the future inputs also. Okay, so these BERT models mainly are very helpful in tasks like which are, they are not used for text generation, because see, if you know what is the next word, there is no point in training. So here we are trying to predict the next word only using this model. Okay, so but here we know the next word, so then there is nothing much to do in the BERT, so we don't use it for text generation. But it is used in most of the NLP tasks like sentiment classification, text classification, or any of the classification discriminative tasks. We can use this BERT models. Okay, so it also uses the self-retention mechanism. Only thing is it is bidirectional, means from the future input also we will use here. Here we are using only the past samples. Okay, so let's go to some evolution of GPT. So GPT 1, which was released in 2018, it had like 4.5 GB of text and 117 million parameters. So it gave reasonably good results for many tasks. Okay, and it could be fine tuned for tasks like language translation, sentiment analysis, and text classification. Okay, then in 2019 they released some a very good version of GPT, which is GPT 2. It trained on 40 GB of text, means the amount of text is increased, and parameters, this is only 117 million parameters. In this GPT-2 we got 1.5 billion parameters, so the number of parameters also increased, and the amount of text is also increasing. So we are seeing this large language model. It is, so from a very small 4.5 GB 117 to we have reached to 1.5 billion and 40 GB in the GPT-2. So it was able to generate very nice text. Okay, for the mainly text generation, it was used to do a very nice job. So the OpenAI felt uncomfortable while releasing this model. They thought this model can be misused. That was the accuracy of this model. Till that point, 2019, whatever the models used to generate text, they were all not that good. They were never like human. But this model, GPT-2, the output was very coherent, and it was like human-like. Okay. And also we can use it for all the tasks like we use it for the GPT model. GPT-2 also was used finally, but this model is released. Means if I want to use any model, the only available model is GPT-2. Okay, so from the OpenAI, this model is free. Means you can access the weight parameters. We can fine tune for any application. But after this, the models are not released. Okay. So,
Hello.
Hello.
Hello, sir. Can we use ChatGPT for Indian languages?
Yeah, that I'll come. Okay, within another 5 minutes, I'll come to that. Okay, I'll come to that. Okay, so GPT-3 used 570 GB of text and 175 billion parameters. So you can see how much the size of data and the parameters is growing, and it's much more bigger. So this was the accuracy of GPT-3 was much better than GPT-2. And one very key idea of GPT-3 was it used something called few shot training. Means so instead of just giving the zero shot learning, means we just give only the question. see, we need to give the input, right? To generate the output, we need to give the input. So the idea used in GPT-3 is something called meta learning. That is learning to learn from the input itself. Okay. So for example, so zero shot means we are not giving any information in the input. One shot means we give some information to how to do it, how to do a particular task. For example, let's say I want to find antonym. Okay. And we will give one example like good and bad. So in the zero shot, we say obtain the antonym. That's all. Okay. But in the one shot, we give one example like we want antonym for a word, given input word. For example, good is there, then it is bad. That is one shot learning. In few shot, we give few examples in the input itself. Okay. So then what GPT-3 did is they trained this model with many such examples where we will give in the input itself, we give the what is this, good, bad, this type of inputs, few examples like input output pairs we are giving in few shot, and we train the model using such examples. So now the model is able to learn from the input itself. It is not like the model parameters are tuned, so we are able to tune the model itself. Okay, that is what is the beauty of GPT-3. And for example, here we see here the sticks. You want to rearrange this word, we in zero shot we gave only one example, or we just said unscramble the letters into word. And here we said, okay, so unscramble, and also we gave one more example, that is chair and chair. And in the few shot we give couple of examples to unscramble it. So when you give something like that, the performance improved. Okay, so this is some simple example of how the performance improved. So let's say these are the points of this is the zero shot point. Okay, here, and this is one shot point, and here the number of, with more number of examples in few shot, how the accuracy is increasing for some tasks like classification task or any text classification task. Okay, so what happened is, and this x-axis is the number of parameters, sorry, number of examples. Okay, this is number of examples in the input itself. Okay, and these different colors will indicate different number of parameters. Okay, so you can see the accuracy. This is 1.175 billion parameters. For few shot learning, you see if the number of parameters is less, the accuracy is less. It's around 30 only. But when we used the large number of parameters, this few shot learning helped only in case of large number of parameters. So if you see the same model, 175 billion parameter, if there is no few shot, the accuracy is very, very bad. So you understand that GPT-3 main contribution was the few shot learning, means giving some examples in the input itself helped to perform better. So what happened after GPT-3? So obviously we would think like we can increase the model size and we can increase the text. That is what happened in GPT-1 and 2. But in GPT-3, after GPT-3, what they did is, one important thing in ChatGPT was they trained it for coding, because see, one of the very important application of ChatGPT is the ability to generate code. Okay, that was not there in GPT-3. So this particular thing, they took a lot of GitHub code and they trained the models. Okay, and another important thing is human involvement. Well, for fine tuning the GPT model, they used human judgments. Okay, using reinforcement learning. So I'll just and that improved the performance. Okay, so very quickly, I will not go very detail into these things because okay, we have some other things also to discuss. Okay. So what they did is, first thing is they trained a supervised model. Okay, you have questions and we have answers. So from that we train a small GPT model. We train it for a small set of supervised data, means input and as well as output. Okay. In the second thing, what they did is they generated multiple outputs for a input prompt. Okay, you ask some question and we will generate multiple output. It is possible using the same model, we can generate multiple outputs in GPT model. This is because there is something called as there is one parameter which generates the uncertainty in the output. Okay, so that parameter they used, and we can generate multiple outputs from the same input. Okay, so they generated multiple outputs and they asked the humans to label these outputs with giving ranks, like out of 10, what is the rating you give. Okay, so once they gave the ratings, from that they trained a model called reward model. Means if there is a response, if there is a question and there is a response, how do I rate that response? What is the rate of that response out of 10? So so they trained using multiple inputs, means large number of humans rated these many prompts. From that they trained another model. This is not the GPT model, this is another model called reward model. What it does, it takes the input and it generates the output, and also for that output it generates the what is the rating for that output. Okay, using this reward model, now we know, like whenever the response comes, it is good or bad, we can know now decide its rating using this reward model. So using this reward model, we fine tuned the GPT model to maximize the reward. Okay, so we main idea here is a reward model generated using the ratings from humans. Okay, by using this framework, we are able to generate a very good response. That is, the chat GPT is able to generate a very nice response because this reward model trained using human ratings. Okay, so and the model is maximized to get the best rating for the input output generation. Okay, okay, so let me come to, okay, this is the, let's stop it with, this is the basic we covered. So we understood transformer networks and the BERT and the GPT models, and also we said that these are all pre-trained models, means they trained only on the mostly on the language models, and they can be fine-tuned for any task on the NLP thing. Okay, so now coming to the performance of ChatGPT in Indian context. Okay, so the ChatGPT is trained using 100 or 99, I don't exact number, it is 99 languages. Okay, it's not English, not only English. So it is trained using 100 languages. Okay, so but the amount of data used for these languages is different. Okay, so this English has the major part of the text is English, and a small amount of text for different languages. So if you try chat GPT in Hindi or in any Indian languages, it works. Okay, many Indian languages are supported in chat GPT. Okay, you can even use the, you can type your questions in Indian languages like Kannada, English, Kannada, Hindi, Malayalam, Tamil. So we can try, we can type the text in Bengali. So we can type the text in that language itself. Now, need not be the Latin script of English. We can type the questions in that our own language, and it will give you the answers in that language. Okay, so the ChatGPT model can answer the questions in Indian languages as well. Okay, may not be all, but several languages in which there are number of users are maximum. So ChatGPT is able to give some response. So I tested a couple of them. I felt like Hindi, it is doing much better than Kannada. Okay, I am from Karnataka, so I tried Kannada also and Hindi also. The Hindi was doing much better than Kannada. The only reason could be the amount of data available for the Hindi language was much more. So the OpenAI was able to access this Hindi text, and they trained their model using that Hindi language. Whereas Kannada, it is little bit lesser than Hindi. So the performance was not good. Okay. But the question is, so why? First question is, this ChatGPT is a single model, but it is able to do for all the languages. Okay, so all those 99 languages. Why somebody wants to do like that? So if I want to do, let's say I would like to train only one language. Let's say I want to train only on Kannada language. Okay, why to train using multiple languages? Okay, first question. The answer for that is, see, many languages have some similar text. What I say is a structure. Okay, language structure. How do they use the genders? How do they use parts of speech? So the many languages share some similarities. So when you train a model using so many languages together, that is when you do a multilinguistic model, people say it will perform better. Okay, but there are some results. I have seen some of the papers where say monolingual models are better than the multilingual models. We'll show some results also. Okay, So that is one thing. But one big advantage is using single model, you can do anything. That is the big advantage. So most of these large language models, they don't just train for English, they're also trained for many different languages. Okay, but the performance is different for different languages based on the amount of data of that language used in train. Okay, so this is, I'll give you one simple comparison for an Indic data set. So this is the Indic QA data set. It has 11 Indian languages. I think Kannada, I don't know exactly list. Kannada is there, Bengali, Tamil. I have to check exact languages. I don't know, but 11 Indian languages they have used. Okay, so this is the performance, the accuracy or the F1 for different three different models. Okay, first one is the GPT-3. The GPT-3 is what? The GPT-3 is the one in which we had few shot learning, but that is not the chat GPT. Okay, the second one is the chat GPT or GPT 3.5 they call it, and then there is one particular model called IndicBERT. Okay, so this IndicBERT is a model which was trained on large amount of Indian language text. Okay, so this is from IIT Madras. They trained this model using the BERT model. Okay, they mainly trained the BERT model, and this accuracy is for classifications. So this is the IndicBERT. So we can see the IndicBERT, the BERT model is performing much better than the chat GPT model also. Means, so chat GPT model is not that good at for the Indian languages. Okay, you can use that. You can always use the chat GPT for Indian languages. We can generate text, we can ask questions, it will answer a lot of things, it will do, but the performance is not as good as, if you see the performance of chat GPT for English, it will be much way better than this whatever we are achieving here. Maybe we are around 25, so it is 25, another 10, maybe 35. So it is approximately 50% accuracy. Means 50% of the times the answer generated is not correct. Okay, so that is the current situation. I think this is from the Microsoft paper. I have not put the reference. I'll put the reference and share the slides. So this is from that paper. This is, so they have generated these results, or they have taken from somewhere. Okay, so these models and all, they have given these accuracies for the in the Indian language, 11 Indian languages. Okay, so what is the problem? Okay, so the main problem is there are two basic problems. The first is we do not have access to the data. Okay, that is, other than in English, we don't have access to the data. That is a big problem. So it's a very big problem. It is not a small problem. You may say, I will go and get some text from some web pages and all those things. We cannot use the data from web page or the websites, because we need to be very unbiased, okay, in our responses. If you take the text from the internet, in many of the cases the texts are biased. Means probably there may be some hate speech, there may be some bias towards their culture. So there are the data which we get from that may not be the correct data. Okay, you may get the lot of Indian data, but may not be correct data. Then whatever model you generate from that may not be useful, because we want to have a, see, one of the biggest thing from GPT-2 to GPT-3 and chat GPT is they were able to remove these biases by using these human in loop training. Okay, so that is able to solve those problems. Otherwise we need to do the same process for our own Indian text also, and I'm sure many of the data available on the website is very biased. We can't use it. Okay, then the second thing is, I told you, as I told you, GPT-3, 3.5 are not available for fine tuning. So we cannot fine tune those models for Indian languages. Okay, so this is a very big bottleneck. Okay, so this is one of the challenge. So we don't have the access to models, so we have to build these models from the scratch. Okay, so definitely I'm not saying that BERT is going to be the best model. We may have these the decoder only models like ChatGPT. It may perform better, but we need to do all the things which are done in ChatGPT, like human in loop training, get large amount of data, do human in loop training. Okay, and lot of fine tuning of the model. Okay, so these are the problems. So what are all the strategies? How do we do it now? One of the strategy, one of the solution for this is collect data. Collect data, which is very, very tedious, but collect the large amount of data for that particular language, then fine tune that model, use and train that model. It will do better. You cannot have GPT-3 and GPT 3.5 or 4, but in the research community, there are many large language models which are not as good as ChatGPT, but they are reasonably good models, and they are shown to perform well for many what is that tasks. Okay, we can use those models and fine tune them for our Indian language. Okay, so I'll go through some of the strategies used by this Microsoft paper which I was referring, which this whole talk is on that particular thing only. So inspired by that. So one thing is use that, collect the data set and prepare data for training using that language, and fine tune few short examples and everything you do, and you may get good accuracy. So then there is one very interesting approach. Okay, so what is that approach is translate test. Means, so see, we have even though these text generation models are poor for Indian languages, but translation models, means if you want to translate from English to an Indian language and Indian language to English, they are there from a long time and they are doing well. Okay, so they do well. There are good translation models. So what we can do is we have a data set in English, so we can translate the use those models. Or what we can simple approach is, whatever, see, you given a question in the Indian language, convert that to English and generate the response. That is a major part, right? So we generate the response in English, and once we generate the response in English, we convert back to the Indian language. Okay, so what is the approach here? Translate test means, see, first we take the query in Indian language, we translate it to English. Now the major task of generating the response is in English only. We use a ChatGPT or some model like that. It generates the response. Now we take that and translate back to the Indian language. This is one one approach for solving this problem. So we can use the existing ChatGPT model or large language models, and with the help of the translation models, we will be able to do better. Okay, this is one approach. So instead of English, we can also have some high resourcing language. For example, the Kannada may be more closer to Hindi than or Sanskrit than the English. Okay, so what, instead of translating through the English, we can also translate through some high resource language, something like Hindi, from Kannada to Hindi or Kannada to Telugu. If let's say you have access to Telugu more data, then we can translate Kannada to Telugu, and Telugu, we do it in Telugu and come back to Kannada. Okay, that is also another approach. Then there is another approach is sort of what is that, ensembling. Okay, what we can do is we can have have responses using all three models above, like that is monolingual model, translate test model, and similar high resource language model, and then let them give some confidence scores also, like what is the confidence of their text generation. So, and then what we can do is we can aggregate. Either we can use maximum, okay, maximum, whichever is the model is having the maximum response, we take that, or some other way of combining the responses and use that response as the final response. This is like ensemble modeling. Okay, so we can take all the three above models and generate three responses, and from those three responses generate the best response and give it as the output. Okay, that is one option. The last option is the same as the fourth one, but what we do is so we convert the responses from the above three models into English. Okay, and generate the we aggregate using those English generated text, and then finally convert that into the original native language. Okay, so I means instead of using their own models, we will use the English as the part to generate the response. Okay, so these are some results from them. Okay, so this is the using GPT-3 and this is using GPT 3.5. Okay, so these are different languages. AS means Assamese, Bengali, Gujarati, Hindi, Kannada, Malayalam, Marathi, Oriya. I think these are the Telugu, Tamil, and PA is, I don't know which language is this. Okay, so these are different strategies and the accuracies across them. Okay, so we can see the, for example, Hindi, the translated version worked well. Okay, 0.51 point, and Kannada also translated version worked well compared to all other 4 strategies. Okay, okay, and but for example, Assamese, the aggregate worked better than the other approaches. Okay, so aggregate source, this English in between did not help much, but this one I think we can. There are many. This translation approach and the aggregate approach, as we can see, many of them are performing better, but this is with respect to GPT-3. But when we went to GPT 3.5, so we can see that many monolingual models, means using that own language, always perform better than these other strategies in for many of the cases, and some cases translation is still performing better. So what we can conclude from this is there is no one exact model which will do better. Okay, some are doing in monolingual model and some are doing in translation. Definitely using translation strategy is a much better approach than just using the monolingual models, especially if you have a, see, GPT 3.5 is much bigger model, and we don't have access to its capability because the model is not free, whereas GPT-3, many models are there which are similar to GPT-3. Okay, and we can fine tune using translation model. So if you want to start somewhere, I would suggest use the translation approach. That is, take the query and translate it to English and then obtain the response in English and convert back to English to your own language. So it will do better. But only problem is in this is how good is your translation. See, these results are getting better because your translation model is better. Means converting from Marathi to English or Kannada to English is much better. Okay, so if that is not there, then this approach may not be helpful. Okay, so in ChatGPT we saw that many monolingual models perform better than the multilingual models. Okay, so there is one more approach. Okay, they tried one more approach. They tried 3 approaches, but I'm going to discuss only 2 approaches. So the second approach is the main idea is use embeddings. Okay, so what we are not able to exploit is, we are not able to exploit already there are a lot of models available in the what is that Indian context also. So we are not able to exploit them which are already available. Okay, so to do that, what we do is so we extract some embeddings. Okay, and you have, let's say we create a lot of documents. Okay, and from those documents we so first we create a knowledge base. Okay, we create a knowledge base with lot of documents, and we create embeddings for the using that knowledge base documents also. Then we, whatever query is there, we first obtain its embedding. First, for a query we have created a knowledge base and embedding using that. Next, whenever the question comes, we create a embedding for that. Now we search that there will be document embeddings also. You have a lot of documents. We search the this knowledge base, which is the closest embedding is closest to which document embedding. Okay, and we take the top k documents, and then what we do is we forward these documents along with the original query to some LLM model. Okay, So I'll tell you, I'll explain it in a much more simpler way. So what we do is we create a set of documents related to our problem. See, for example, I'm working on insurance customer support, okay, in India, in Canada, okay. So what I'll do is I'll collect all my documents and I'll store it in the some knowledge base, and I'll create an embedding for these ones, okay. And then I will query. I will also create an embedding for my input query and use this input query to search which documents are important in the knowledge base and take the few of those top few of those documents and use that as input to the original query. Okay, and LLM is there. LLM language model is there. That is there. There is a language model which is trained using either use translation or anything, but we can improve its performance by using what is this, using additional information, like we know only these documents are going to be used in my application, so I will create an embedding using those applications, and I will search which are all important documents, and I will give that as the input to the LLM. Okay, so what is the point in giving documents as input to the LLM? See, we saw that when we gave few shot learning, that is, we gave some examples, it performed better. Okay, so by giving appropriate documents as input to the LLM, we will perform better. Okay, that is the idea of not just using the fine tuning model or anything. We helped the model by giving some more information in the input itself by using this query and query search in our knowledge base. Okay, so that is the one model. Okay, so this is the gain which they achieved using this approach, where they combined the large language model also, and they used embeddings and searching in their own knowledge base, and they created some inputs from those knowledge base and gave it as an input to the LLM. So they saw that the performance improved in, see, monolingual model, it improved. Third one is this using some high Indian language also performed better gains in all the case. Aggregation also, it performed better here. Okay, so we are able to gain in all the models. We are able to gain something. So by giving appropriate inputs, we are able to generate a better output. Oh, sorry, I think I crossed the time. Okay, that's the idea. So in summary, ChatGPT is still not the best for Indian languages using basic strategies. So these strategies are used by these, which we discussed, these strategies to improve the performance. They are used in many other papers also. And when they tried it for Indian context, they found there some it performed well, some it did not perform well. But when we use the embeddings also along with the embeddings and search documents, that resulted in a very good improvements. Okay, and one of the problem of these models not available, we can also solve it using knowledge distillation. Okay, what is knowledge distillation is, we know we don't have the access to ChatGPT, but we have the access to input and output, so we can generate lot of input and output using this ChatGPT model, and we can train our model using that these input output page generated by ChatGPT. So that is also one of the solution to the above problem. So that's all from my side. If you have any questions, we can take up now.
Hello.
Yeah.
Sir, the one problem is that Google Translate is not properly done translation of Indian languages. So
Yeah.
we are not getting the good result for Indian languages. We are not getting maximum. We are getting 50%. So
Yes.
is it helpful for real-time application?
Okay, so the accuracy is not up to the mark, so it will not be good. So that is where is the scope. Okay, so you can definitely, we can't use it if that accuracy is that bad. We cannot use it, but there will always be some applications where we can use, even the performance is not good. Let's say you are 60%, but we can always use it to help somebody. Means we can give, this may be the answers. Okay, nobody is bothered about correct answer. We will say these are maybe the answers. It may help. Okay, see, for example, there are some government documents in Kannada. Okay, and I want to, okay, translation you are asking, right? So you want to convert to English to Kannada. but there is no, it will give us some basic translation content. We can use that as well as some basic part, and then further use it to fine tune it using humans or something like that. So even though performance is 60%, we can still use in some applications, but definitely it's alone is not useful. Okay, just I want to use that, like ChatGPT, the level of accuracy ChatGPT is able to do it, definitely we can't. But even with 60% also, we can use it based on conditional outputs. Means, okay, this much accuracy I will give you, work on later, you can work on that. Yeah.
Hello, sir.
Okay, thank you, sir.
Hello, sir.
One more question, sir.
Huh.
Can we develop a bot-like model for some specific application if we
Yes,
have
yes.
a large amount of data?
Yes, see, already models are there. So these are available in Git also, GitHub. These BERT models are available in GitHub. So you can fine tune models. And also there is a multilingual BERT, okay, MBERT, okay. These models also you can use those models. You can use those MBERT type of models and fine tune. IndicBERT is there. So you can use those models and fine tune in using your own specific application. Definitely you can do. Okay, this is regarding
Okay, sir. Thank
translation
you.
or what? This is regarding what? This is just using BERT, right? We can use Indian, those BERTs are available, IndicBERT and all those models. You can just fine tune.
Yes, sir. I have tried all these birds version, but maximum the accuracy is 55. 55.
So we need to do some, what is that? Some out of the box thinking. So like generating the text using these translation models, which we discussed, that the approach which they use, translating using English. So that approach, or you can create text. For example, let's say we have a translation model. Okay, your problem is itself is translation. Is it?
Yes.
Is it your?
Yes, yes.
Okay.
I have tried for original data as well as translated data. Both are not provide high. Yeah.
Accuracy. So then we are left with no other things as like we need to create a curated data set, and we need to improve on model. Okay, take different models, and let's use something like reinforcement learning type of paradigm for your problem. So we need to come up with something out of the box there. If it is, even if you are doing that, it is not coming. So we need to do something out of the box there to solve that. Okay, it's not straightforward just taking some model from somewhere and fine tuning.
Okay. Thank you so much, sir.
Yeah. Yeah.
Hello, sir. This is Shan from
Yeah.
Kalani. And sir, it was a great session, and actually got to learn so many things. So I have a small question. Sir, please suggest any method or any model for named entity recognition task.
I'm not able to hear you.
Sir, for named entity, any task actually.
Named entity recognition.
Yes.
Named entity recognition, which models you can do? Actually, nowadays, ChatGPT does named entity recognition. So it has got APIs from which you can actually get named entity recognition. Okay. So yeah. So, but you want free? I didn't work much in this name entity recognition model, but there are many language models, okay, large language models, which you can fine tune for this problem. See, for example, even what is this chat GPT is able to do the name entity recognition because it is basically pre-trained on large amount of text. So same way you can use, there are freely available language models like Llama is there. There are many models are there. Okay, just search large language models, freely accessible. So there are many models. So you can take any one of those models, and you see they have given the accuracies also. You will be knowing they will report all the accuracies of these freely available models. So you can choose one of them and fine tune for your named entity recognition model. Exactly, I don't know what is the state of art there. Okay.
And so one more question here. For question answering, actually we can do with the text and from the knowledge graph basis. So like which technique is much more better?
Which
technique? With the knowledge graph or with this like building some data set on the text JSON.
Definitely the models. I would say just doing basic NLP will take a lot of time to do anything. So what you can do is, for example, the way these people did, right? They gave the documents as input to the deep learning model, the LLMs, okay, which improved the performance. So you should do some tweaks like this, where you will use some knowledge also into the model, okay. So means we can use that as input and learn that. So something like that is good, but definitely using only the knowledge based and what is that the old NLP style of processing is definitely not going to get you to the good accuracy. So you should use these models is what I suggest.
Okay, sir. Here, one more thing. If we just give the document, suppose today I have trained with thousand of pages of the document,
Okay.
and suppose in the next year it becomes, let's say, a lot more pages. So, do we need to train it further, or should I just hyper tune the models?
So you have a model which you trained using some data, okay, large
Yes.
amount of data.
Mm-hmm.
Okay, you're trained model, and now you get another small amount of data. What we should do is your question. I'm
Yes.
not able to.
Yes.
So you see, we already have the model. Initialize the model using that model. Okay, parameters are there which we have left there. Okay, we trained a model, then we can store the weights, right? So we can
Yes.
store the weights, and then when we start to train for another additional data set, first initialize the weights using that weights and fine tune it for this new data.
Okay, sir.
Okay.
Okay.
Yeah.
Thank you very much, sir.
Yeah.
I hope this question, in case of code mixed Indic low resource language like Gujarati or Marathi, what is best possible way to use LLM? I mean, without translation. So this is another question.
In case of code mixed Indic low resource languages like Gujarati or Marathi, what is the best possible way to use LLM? Okay, so if you see ChatGPT's response now, so it's always it allows, because it is the model. Okay, so it's basically how the data is given to it. So if you want to do code mixed responses, then I should have that thing in the training itself. So if you have the training, it is there in the training, it will do well. If you don't have the code mixed inputs in the training, it won't perform. But I have seen myself, I have tested a couple of things when I use especially when we are writing in Indian languages, we don't get the words for some of the our own language words, so we tend to use English there. So it performs reasonably well. Okay, so code mixing, it performs well, but again you have to quantify and all. I'm not aware of how they have quantified the accuracy and all those things, but with what is that, with some of the examples I tried, it worked. Okay, and if you want to improve the performance, again you have to train using such mixed code mixed inputs. See, you take the questions in which the Gujarati and English is mixed, okay, or Gujarati Marathi is mixed, okay, then train using such data, okay, fine tune using such data, then you will be able to do better. That is the way to do it for the mainly focus on training data with code mixed inputs. That is what I would suggest. But what for the short form, like good night, how to achieve correct word for the short form? Yeah, like, see, so they okay, this is very interesting. Like many people type such type of things in the text, and we need to do that. So see, usually in if you give the chat gpt with so they've trained we need to train with some examples. See, need not like all the examples we need to give it, but chat gpt with few short learning, it can if you train it using a small set of examples like this, I would say it will learn by itself say for example, here you used night, N8, okay, N8. Okay, now it understood that, okay, if you give some examples, it understood, okay, the 8 can be used as it of a word. Okay, so it learns from that. So you can use few shot learning. You can give such examples as a few shot learning part and train the model, or you can try, you just chat GPT, you try. Okay, you give this correct word format. Like if you give this and you ask some questions, it will do reasonably better. It may not do it perfectly because it is not such problem is not been focused. This is very new problem. Okay, especially when we are using WhatsApp and all, people tend to use such things. But I feel like in the few shot learning, it should do well in GPT-3. Means based on the few shot learning strategy used in GPT-3 and ChatGPT, it will still be able to do something, but may not be all, because it should know these, right? So right, N8 night thing, it should know, then only it can do. Okay, so but if you mix these things in a word in which you mix the 8 and also using multiple O's, it may do, it may still be able to do it, but we need to have data like that only to train that. Okay, so any more questions?
Thank you. Thanks a lot for the presentation.
Yeah, I'll share the slides with the reference to the paper. Okay, so I just took some part of that paper. That paper is a very big paper, so I'll give you some references for that.
Okay. You can give the email ID nataraj@IIIT.
Okay, so my email ID, I'll put it here in the message box.
And so there will be tomorrow also, there will be session starting from 10 a.m. onwards. So please join. Nishita.
Thank you. Yes, sir. Thank you, sir, for your enlightening words. As we conclude this enlightening workshop for today, I would like to express my heartfelt gratitude to all the speakers for sharing their immense knowledge and expertise with us. I appreciate all the attendees for their active participation and valuable contribution. It's been a pleasure hosting this workshop. I hope everyone leaves today with a greater understanding and new perspectives. Let's meet tomorrow at the same time with the same enthusiasm. Thank you, everyone.
Okay, thank you.
Thanks. Thanks for